Alright. Starting chapter 2, finally. Okay, we're talking about quadratic functions. So remember we talked about parent functions? So our parent function this time is x squared. Do we remember what these graphs look like? They're looking like the parabolas. Those are the u's, right? So if it's positive, it's upright. If it's negative, it's upside down. Okay, so we're dealing with parabolas in this chapter. So that was my parent function, and we know the parent function starts at what? On the graph, where does the parent function start? The origin, right? If I change this like this, we can describe how it's being moved, right? Yeah. Just by looking at that. What does this minus 3 tell me? Right 3. So remember x, we have to think opposite. What does this plus 2 tell me? Up 2. So that would give us our new starting point, right? So if I wrote that as a coordinate, my new starting point, if we went right 3, that would be a positive 3, and up 2 would be a positive 2. That's my starting point, right? This point right here, that's called the vertex. Okay? What? Not yet, no. So that is my vertex. We're going to talk about writing equations in vertex form today. Okay, so we've already been dealing with the vertex, just not in this form. Okay? In the margins of your notes, I want you to write down this equation. Okay, and I'll write it a little bigger here so we can talk about it. I want you to write down f of x equals a times x minus h squared plus k. That is the standard vertex form that we've kind of already been dealing with already. Okay. To label some things here, I want you to label these also. We have A. That A tells us the direction the parabola is going. So that tells us if it's opening up or opening down. So remember at the beginning of this, I talked about if it's up, that A is positive. If it's down, that A is negative. Okay, so that's what the A tells us. The HK, we just talked about it. That is our vertex point. So if I have this vertex here, or that parabola, the vertex is here. Okay, or if I had an upside down one, the vertex is here. Okay, couple things I want to point out with the vertex. Okay, we're going to be talking about maximums and minimums. Okay, if I'm looking at this first one right here, everyone with me? Looking at that one, is that vertex a minimum point or a maximum point? Minimum. It is minimum because it is the smallest value on that graph. So that would be a minimum. What about the graph on the right? Is the vertex a maximum or a minimum? Minimum. This one right here. Maximum because it is the highest point on the graph. Okay, so we get that minimum and maximum depending on where the vertex is. If the vertex is on the bottom, it's a minimum. If the vertex is on the top, that's a maximum. Okay? That's a majority of it from that equation. What do we normally think f of x is when we change it? What's f of x stand for? Y. And then we have our x in here. That's our different point values if we need to use those. Okay? I'm just going to throw a random example in here. If we talk about f of x equals 2 times x minus 3 squared plus 2. Now, again, this is just a random one. I would write it down so we can talk about some of these things. Okay? What is my A value? 2. A is 2. Okay, is my parabola opening up or opening down? Is it upright or is it upside down? Up. It's up, yep, because that A is positive. Good. What is my vertex? Remember, that's my H and K. 3, 2. Why did you change the negative 3 to a positive 3?
Because we need to think opposite.
Yep, we need to think opposite. Good. Okay. Is my vertex, which in this picture my vertex is here, is that a minimum or is that a maximum?
Minimum.
It's a minimum. Yep. Good. Questions about naming different things? Okay. We're going to talk about a couple different things, but those are the main ones. Let's look at example 1 in your notes. Okay. 0.4 to a 2. Change that 0.4 to a 2, and then draw your x and y axis for me if you haven't already. Okay, so now we are actually graphing this function here. Okay, so bear with me on my graph here. So let's label some things. What's my a value? 2. Opening up or opening down? Up because it's positive. Okay. What is my vertex?
3, 0.
It is 3, 0. Where'd you get the 0 from?
Because there's no number outside.
There's no number on the outside. Yep. So my vertex is 3, 0. So go plot that. 3, 0. Puts me about here. How do we get all of the other points for the parabola? Right, it's that step pattern, right? I want everyone to write that step pattern down. Is our step pattern going to stay the same?
No.
Why do you say no?
Because it goes over 1, up 1, over 1, up 3, over 1, up 5, over 1, up.
Yep. So what's different about our step pattern that I have to be careful with is this a value right here is going to change it. Okay. If we have a specific a value that's not 1, we have to change our step pattern. And the only way we do that is we just multiply our step pattern by whatever our a is. So I'm multiplying every step by 2. So multiplying every step by 2, what's 1 times 2? 2. 2, 3 times 2? 6, 5 times 2? 10, 7 times 2? 14. So this pattern right here is my new step pattern.
So it's going to be over 1 still?
Yep, it's still going to be over 1. So I'm going to go over 1, up 2, over 1, up 6. And then I fall off the graph. How do I get the other side?
Same thing.
Same thing. Over 1, up 2, over 1, up 6. And then draw your picture. So if we have an a value, that changes our step pattern. Okay, a couple things I want to answer. Is this a maximum or a minimum? Minimum, good. What is my domain?
Infinity.
What's the least x value?
Negative.
Negative infinity. What's my highest x value?
Positive.
Positive infinity. Hint, for all of the quadratic functions, your domain is always going to be this.
Always the same.
For all quadratic functions, it's always going to be the same, no matter what. Even if it's opening upside down. Okay? The range, what is my lowest y value? It is 0. What's my highest y value? Positive infinity. Now, the range will not always be the same. Okay? One more thing we need to talk about, and that's axis of symmetry. Okay? You can label that bit capital A, little o, capital S. Axis of symmetry. What does symmetry mean to you?
Same on each side.
What do you mean same on each side?
When you cut something in half, it's the same on left and right.
Right, if you cut something in half and you fold them together, they are the exact same. It's like a mirror image, okay? Where would that point be on this picture?
0, 3. Or 3, 0.
Would the axis of symmetry be this way?
No, there's a lot.
It'd be this way, right? So, to describe the axis of symmetry, what point does it go through?
3.
Goes through the vertex, right, at 3. So my axis of symmetry is x equals 3. Now notice the relationship here. That axis of symmetry is always going to come from the x value of your vertex. Okay? We have to put x equals, because if you just put 3, that doesn't tell me anything. So we need that x equals 3 to tell us exactly where that axis of symmetry is. Okay? Okay. I want you to go try and graph B.
I do not know how to do that.
Okay? Go try and graph B. All right. What is my A value? 3. What's my vertex? 1, 2. What is my original step pattern? 1, 3, 5, 7. Always start with your original step pattern. Now ask yourself, is my step pattern going to change? Yes. How? Multiply by 3 to all steps. Now, are you going to use all the steps? No, but you still want to multiply by 3 for all the steps. Okay, what's 1 times 3? 3. 3 times 3? 9. 5 times 3? 7 times 3? 21. Okay, so am I paying attention to our original step pattern anymore? No. Okay, we have a new one. Now, let's graph. Where's my starting point at?
Over 1 up 2.
1, 2, that's the vertex. Okay, now I go over 1, up 3, over 1, up. I fell off already, right?
9.
So then over 1, up 3 on this side. And then draw your picture. What should I have checked first?
How do you know when it's negative or not? How do you know like what
The A value? Yep, that's what we need to check. The A value here is going to tell us if it's going to open up or open down.
will be negative if it's going down?
Yes.
Okay.
Yep. Since it's positive right now, it's opening up. If I had a negative here, we would be going down. Okay?
Is it because you multiply your step by negative?
Yes, so then that makes you go down. Yep, good. Okay, couple things we need to answer about this now. Okay? What did we say the vertex was?
1, 2.
1, 2. Is that a minimum or a maximum?
Minimum.
It is a minimum. Okay. Next thing is axis of symmetry.
X equals 1.
Where do you get that from?
The X in the vertex.
Yep, and why do we have to have x equals?
Because if you just say what, it can be Y or X.
Correct. So we have to have x equals 1. Good. What about domain?
Negative infinity to infinity.
Why do you get that?
Because it's going to be the same no matter what.
Yep, negative infinity to positive infinity. Range.
I got 2 infinity.
2 infinity.
It is to infinity. Our lowest y value comes from here, and then we go up to infinity. Awesome. The step is different. Yep, I want to look at change that equal to on your notes. So it gives us this function here. It wants us to identify a few things. Can you still identify these without the graph?
Yes.
You can. Okay. We just have to visualize it a little bit. What is my vertex?
Negative 4, negative 5.
Negative 4, negative 5. Good. What is my... Ooh. Is it a maximum or a minimum?
Maximum.
Where do you get that from?
Because it's going to be
It's
upside
going to be
down.
negative. It's going to be upside down. That
Yep.
A is negative.
Yep. So if I talk about our A for a second, our A is a negative 1. Say that. Okay, so that tells us it's going to go down. Well, looking at this picture here, my vertex, is that a maximum or a minimum?
Maximum.
It's a maximum. Good. What was the second thing it wants us to find? We found the vertex.
Domain, range. Axis of symmetry.
Yep, let's do axis of symmetry. What is my axis of symmetry?
Negative 4.
What about negative 4?
X equals negative 4.
Yep, x equals negative 4. Good. 2 more things. Domain
Infinity.
and range. What's domain?
Negative infinity to infinity.
Yep, always going to be negative infinity to infinity with these functions. Okay, range. A little trickier. What's my lowest y value?
Negative 5.
Careful. Keep in mind, my picture looks like this. What's my lowest y value?
Negative 5.
Negative 1.
My negative 5's up here.
Negative infinity.
Negative infinity, because my lowest here is our negative infinity points. My highest is negative 5. Yep. So if you're given a equation, if you're given an equation and it doesn't tell you to graph or anything, draw a little picture so you can see what that parabola would look like if it was on a graph. Okay, now it doesn't need to be exact, you just need to know if it's opening up or opening down so that you can use it to help you answer those questions. Okay? Look at example 3 in your notes. Here, let's look at what it gives us. Okay, it gave us the vertex. What's the vertex? 1, negative 4. And then it gave us a random point. Now, when we're given a point, what are points normally said as? What do they represent? X and a coordinate, which is an X and a Y. Okay? What we're doing now is we're writing our own equation. Okay, so the equation we're going to use is our f of x equals, it's the one I had you write down at the beginning. F of x equals a times x minus h squared plus k. So I want to label some things. What letters does the vertex stand for?
X and Y.
No. Vertexes are H and K. Vertex is H and K. What does the point stand for? X and Y. If you're given a point, it's X and Y, but our vertex is noticed as H and K. Okay? So I have labeled all of my things. Now I need to plug it into the equation. Well, what does f of x stand for?
Y.
F of x is our y. What is my y value?
-1.
-1. Do I know what a is?
No.
Did I label anything a?
No.
Nope, so I'm going to keep a as a. What's my x value?
-2.
-2 minus, what's h?
And 1.
What?
1.
1. Yep, so -1, and then I have squared. What is k? -4. So now we just have an algebra problem that we need to solve. Okay, what needs to happen first?
+4.
Not yet. Order of operations, what do we need to do?
Multiply A.
We need to solve what's inside here first, right? What's -2 minus 1? -3, and then I still have squared here, -4. What's next?
Square it.
Yep, -3 squared is?
-9.
Negative times a negative is?
Positive.
+9 minus 4. What's next to get a by itself?
Divide by 9.
What's first?
-4 or +4.
Add 4 to both sides. So I have 3 equals a times 9. Now how do I get a by itself?
Divide by 9.
Divide by 9. So I get a equals 3 9s. Can I simplify that?
1/3.
Yep. 3 goes into both of these, so I get 1/3. Now, that is my a value. That's not what we're looking for. What do the directions want us to do?
Vertex.
It wants us to write the equation in vertex form. Okay? In order to do that, we need the a and the h and the k. Do we have all three of those things right now?
Yes.
Yes, so we can rewrite our equation. Okay, so my equation would be f of x equals, what's a?
1/3.
1/3 times x minus, what's h?
1.
1, and then squared, what's k?
-4.
-4. So that is my equation in vertex form.
The final answer.
That is the final answer. Yep. So we use the vertex and the point to help us find what a is, and then once we found a, we could rewrite our new equation. Okay? Looking at number 5 in the back of your notes, I want you to tell me the vertex. Let's just go through this one together. What is our vertex for number 5?
5, 2.
Careful.
-5.
-5, 2.
Same difference.
It is not the same difference. What is my picture going to look like? Upside down or upright?
It's going to be upside down.
It's going to be upside down. What told you that?
The -a.
The negative. Okay, so my vertex then is here. Is that a minimum or a maximum?
Maximum.
That's a max. Okay. What would my axis of symmetry be?
5. Or x equals 5. -5.
x equals -5 would be my axis of symmetry. What is my domain? Yep, -infinity to infinity. Now a little trickier one, what's range?
Negative infinity. -5.
Now careful, -5 is my x value.
2, I meant.
Yep, I want the y value. So it's -infinity to 2. Good. Do you notice how you can label all of those without actually graphing the picture? Okay. All right. Let's look at number 7 together. Number 7, writing our own equation. What was that original equation that I had you write down at the beginning?
F of x
F of x equals a x, or parentheses, x minus h squared plus k.
Yep. So that's the equation we're going to use. What can we label the vertex? What letters does the vertex stand for?
B, or h and k.
H and K. What does the point stand for?
X and y.
X and Y. Yep. So we're going to plug in what we know. What's f of x?
y
F of x is y, which is -5. Do we know what a is?
no
Nope. What's x?
-2
-2. What's h? Now watch how I plug this in. It's minus h, which h is minus a -3. What happens to two negatives?
Plus.
Make a positive. Yep. So be careful when you're plugging in negative numbers. What's k?
7.
7. Now we just need to solve. So I have -5 out here. What happens first?
You do the parentheses.
Yep. -2 plus 3.
Yes, which is 1.
1 squared plus 7. What comes next?
Square root of nothing.
Yep. What's 1 squared?
1.
1. Do you agree I can just write a here?
Yes.
Yep. Because remember, what number is technically with the a? A 1. Yep. And then I have plus 7. What's my last step here?
-7.
-7 on both sides. So I have -12 equals a. Am I done?
No.
No.
You have to plug everything back in.
Yep, the two things that you need, remember, are your vertex and your a. Now we can write our equation. So my new equation is f of x equals, what's a? -12 times x minus, what's h? -3, so that turns into plus 3, good. Squared, what's k?
7
Plus 7. That is my new equation in vertex form. All right, last one here. What is the equation that we're using to help us solve this? Perfect, thank you.
Is there a name for this equation?
Vertex form.
Vertex form.
Yep, good question. V. What can we label V? Our vertex. What can we label our vertex? HK. What can we label our point? XY. Perfect. Tell me what I need to write to plug in all these values. F of x is y, which is 5. Do we know what a is? Nope. What's our x? 2 minus 1 squared plus 3. Perfect. What do we need to do first? Yep. So we have a times 2 minus 1. 1 squared. What's 1 squared? Yep, so I can just have a here. Plus 3, last step. Minus 3. So I have 2 equals a. Am I done?
Plug it back in.
Right, what are the two most important things we need to write vertex form? A and the vertex. Okay, do we care about the point anymore?
No.
No. Okay, the point just help us find a.
You don't have to write that into the equation?
The point?
Yeah.
No. Nope. So my new equation is f of x equals 2
times x minus 1
Good.
squared
Good.
plus 3.
Awesome. Yep. The reason we don't need the points anymore, this is what it would look like if we wrote it with the points. we'd have 5 equals 2 times 2 minus 1 squared plus 3.
I wrote f of x equals 2 parentheses 2.
Nope.
I only did.
Does this look like an equation to us?
Yes.
Like, it does look like an equation, but...
It's just telling you what it equals.
Right, it already tells us what it equals, right? So when we rewrite those equations, we do not want the x and the y in there. Okay, we want it to look like one of the originals. Okay? Good question.